We now go on to Lecture 8, where Professor Vakkamapana will speak on role of LLM and data analytics in AI/ML.
Yes, everyone, we will ask the question. If you have any query, then at the end of the lecture, we will make the discussion. Okay? Though already spoken the more than 1 hour and 45 minutes, and there is some limit for me also. Okay? So I will just consign this topic and try to cover as maximum. Okay? So now my lecture number 8 is the cost of the LLM and data analytics in the AI. The main agenda of this lecture is the introduction and the history of the LLM, evolution of the and the architecture of the transformer model, heat map analysis of the LLM models, and the Llama and the Gemma for the MHA, GQA, and MQA, and the comparison of the LLM model and impact of the LLM models. Now, before going to start my lecture, I acknowledge all the contributors published their work into the journal. So I thank to them, and I with their consent, I have taken the content of this lectures of this topic. Now, what is the LLM? What is the LLP? Okay, so you know, get the idea. This is my this is the AI. Okay, and you know the deep learning is the subset of machine learning. Okay, then and then only there should be some kind of the feedback, or there should be some benefit to the human beings. So in this case, suppose this might, if I want to make the intelligence, then I have to give the order in the my language. And suppose this same mic will be in the another part of the country, some Telugu state. Okay, at the time this mic should be able to understand the Telugu language. So we need the natural language processing of this machine for the because my intellectual and the person of the Tamil Nadu having the different intellectual concepts, and there are different refinement. So we need the machine to be able to understand the human language, and there is an NLP. So here the purpose is that I can understand the Gujarati and some another language. In the same way, the machine should be able to understand the multiple alien to communication with this one. That's why the NLP will come under the AI, not in the subset of the machine learning and the deep learning. Now, LLM is the brain that will learn, predict, and generate the coherent human language in a given context from the massive amount of the complex data. In the NLP, it may be either in the one format only, but in the large big model, it is a multiple type of the data sets, either in the combination of the text, images, and video from the multiple sources. So there is a difference between the NLP and the large language models. Now, this is a history of the how the large language model are evolved. So from the it is first is in the 1940, the first model based on the AI. There is a Warren McCullough and the Walter Pitt introduced the world to the idea about the alien, and then the first during the 1950 to 60 first language model, which is a rule based, and then it is up to the this 2015. It is a global neural machine translator, and up to the 2023, it is a GPT-4 large language model. Okay, so there are the many models which are known in the different aspect or in different context. GPT is the generative pre-trained transformer, but it is a bidirectional encoder representation from the transformer. T5 is the text-to-text transfer transformer. Palm, Lambda, GRM, Gopher, Jurassic, MT, Energy, Llama, Falcon, OPT, and the Boom are some of the popular LLM models for the language processing or language contextual language generations. Okay. Now, for here it is a 5 category. The GPT, if you just talk about GPT or something, okay. And a second is the conversation data, book and the news, scientific data, and the code. So these are the 5 major category of the LLMs. And this is the size of the data. So for example, web pages, from the common core sources, it will use the 800 GB size of the data by the non-area C4 data set under the category of the web pages. So there are the different kind of the data size, conversion data 800 GB, books and news from the 5 GB to 120 GB of the different source, scientific data and report. Now, what are the percentage of the data set in the training of the large language model? In the Llama, 87% of the your data set is used by the web pages, and 5% from the conversation model, 2% from the book and the news, and 3% from the scientific data, and 5% of the code. In the same way, GPT-1 and GPT-2 use the 70% data from the in the category of the web pages, and 30% books and the news, and GPT-3 use the 84% of the web pages and 16% of the book and the news, and Alpha Code use 100% of the code. So you can get the idea about the what kind of the requirement, what kind of the large model language can be utilized for your point of views. Okay, suppose I want to generate the power, then there is no need to use the GPT and GPT or the models. And if you want to get the code for the particular operations, at the time that you have to use the alpha code large disaggregated model because they give 100% of the code. Okay, so if you suppose the books and the news, it is 2%. So at the time that kind of the output, if you are looking for the this category, at the time it will give the less accuracy about the your output concerning about the contextual point of views. Okay. Now this is the comparison of the NLP and the LLMs. NLP and the LLM. So this would not a type of the tasks are the text classification, information extraction, sentiment analysis, machine translation, large language, and the sentiment analysis. And in the LLM, it is the content creations, virtual assistant, question answering, generating the human quality text, understanding the complex context, and the communication like a person. The method is a rule-based, structure-based, and the statistical-based approaches. And here it is the LLM is a deep learning approaches, transformer-based approaches, attention mechanism, encoder decoder approaches, and the periodization and distributed neural networks. And training, here they use the supervised, unsupervised, supervised, and in the LLM, because of the transformer based and attention mechanism, it is possible to make the training in the periodizations. So data parallelism, pipe training parallelism, tensor parallelism, model and optimization parallelism. A training in the LLM is different than the learning in the deep learning and the machine learnings. Okay. Now this is the architecture of the pro of the LLM. So this is your input text, data processing, and this is the non-real token alias. Now main function is the LLM pistol. I am finding if I am giving the one book and I want to find out the only specific context of the book, then only that context we want to identify from the all the pages of the books. So this can be done by this tokenization. Okay. So here it is what happened in the tokenization. time to explain in the next. So this is all the sentences are converted into the number of the character, number of the word, number of the surface, and giving it a separate level. And meaning of and the every word will giving the token IDs. And based on the token ID, and this has become the vector of the token IDs. It is the numbers. So your text is converted into the some vector numbers, and based on this vector numbers, we want to find out what is the meaning of the particular. So this kind of the phenomena is known. It is happen in the tokenization. Then it is the pre-telling and the parameter tuning, hidden real, attention mechanism, real normalization. So in the case of the deep learning, we are making the train the model by the iterations. But here, if you use the iteration of the iteration method for the training, because of the input text are very large, 800 GB of the data. Okay, then after your training will be taking the much time. It may be 1 year if you use the iterations. So that mechanism is not fulfilled. No, will give the time for the timing will be the large. There is another concept with the platform architecture, where the contexts are divided and the training are divided into the part. That's why it is a parallel training, depending upon the type of the attention and the type of the queries and type of the keys. What keys are you entered into to find out the some particular requirement of the in the content creations in the your large language models. Okay, so here the iteration are not occur, but this is known as your different architecture, which is known as your transformer architecture of the LLMs. Okay. Now, how it is a evolution? Okay, so I just talk about the different the RNN. So that is your dependency of the times and the neural networks. Okay, here the training will be the iterative. So here this will not work. Okay, because of the wrecking of the context. So we are not concerned about the A10 or RNN dealing with the context of the railway, but the able to identify the temporal position to the circular structure and address the gradient vanishing issue using the NSTM, RNN adopted in the language model. Another version of the this NSTA. Okay, so it is the encoder-decoder architecture. What is the encoder decoder architecture? Is using the two LSTM with a varying rates. The encoder LSTM sequentially encode the input into a fixed dimensional vector called the tokenization, which the decoder LSTM uses to generate the output. It processes the token sequentially and improves the NLP task performance due to the long memory LSTM. So here in the encoder, the memory size is less, but the dimension of the input sequence will be the less. And but in the decoder size, the memory size is more, and it will convert into the this what we call language model of the as compared to the RNN. So this is the from the RNN decoder architecture. Then it is the attention mechanism. Okay, attention mechanism is the. So before this one, I will talk about what is the tokenization. Involve the passing the text into the display path, either characters, subword, symbol, or word using the algorithm, word pace, unigram, ln, and the byte pair encoding. And embedding is to convert the text into the lower dimensional vector space to capture the semantic minutes. Okay, so this is for understand the relation between the word. So, a unique number identification is assigned to the each token and connecting the linguistic information to be the numerical vector is called LA. Input embedding the numerical representation of the word. Model is trained to generate the embedding so that a vector of the same size represents the word with a similar meaning. Okay, so you can get the idea if this is my line, what is the meaning of this line or sentence. If you put into this another order of the word, whether it is having the same meaning or not, that can be identified by the calculating the by doing the embedding process. You can get the idea about this will helpful to identify the context of the requirement. Okay, and this is a difference between the different kind of the deep learning. The model performance is heavily influenced by the how words are represented in orders. At the same way, there is another concept is the position encoding. The sequence of the word in the sentence frequently convey the important semantic information. The same set of the word in a different order convey the completely different meanings. Okay, and so understanding of a word order in a sequence is important to identify the correct alternate meaning. In the natural network, the order of the input is not perceived. For contextual sequence, position encoding is used to encode the position of each word in the input sequence and a collection of the integer. So this will identify the order of the word in a sentence to get the whether what is the semantic meaning of the given line or given sentence, and this can be done by the different techniques, sine wave and cosine wave, and at the same way it is used for the rotary position embedding, and that is known as the ROPE, which is used as a rotation matrix to encode the absolute position and incorporate the relative positional dependency into the self-attention. Each preserves the relative distance and angle between the token, enabling the model to run relative positional information effectively. And because of this tokenization, embedding and position encoding, okay, if you integrate and then you are able to get the contextually and coherent semantic meaning from the large input sequence. So this method, tokenization, embedding and positional encoding are useful to get the idea about the coherent meaning or contextual meaning about from the large text sequences. Okay, and this is a concept to use in the transformer model about the large language models. Now, in the same way, in the encoder decoder that I already talk about the encoder and decoder. So here, what is the issue in the encoder and decoder architectures? Okay, what is the issue about the encoder and decoder architecture? Here, they convert the entire input sequence into the fixed length vector, leading to a bottleneck issue and degrade the performance when the input sequence grow longer. Okay, so this encoder decoder can convert the line, fulfill your language model requirement, but when my input sequence will grow, at the time my performance of the encoder and decoder architecture is poor. So how to reduce this issues? At the time it is known as your attention mechanisms. What is the attention? Now, in a given, suppose if you take the one novel, okay, in the novel there are the many aspects about the story. Yes or no? So now, what part of the story you are focusing? So this is the attentions. Okay, so only that part of the attention will be if you find out and giving the output. Okay, so at the time now in the novel it may be anything. The purpose of the killing or something. Okay, so there is the attentions, and if you add this kind of the mechanism in the large language model, then at a particular requirement of your prompting of your requirement, it is easy to find out the output based from your large data sets. And because of this, it is possible. Attention mechanism. The attention mechanism focus on the context generated by the encoder for each decoder output by the formatting the link between the various tokens. So there are the many type of the attention, self attention, cross attention, scale dot product attention, multi-head attention, group query attention, and the multi-query attention and the fresh attentions. Okay, so here the self attention where all the query and the value come from the same encoder and decoder. Cross attention from the when the output of the encoder block is used as a query of the immediate decoder block. Okay, so these are the I will discuss the scale dot product attentions. What is a scale dot product attentions? Now, how to find out the attention values? How to find out the attention values? Okay, it is a find out from the scale dot production. It compute the dot product between the query and the key matrices to measure the similarities. And the resulting product scaled by the factor 1 by under root dk. Dk is the dimension of the query or dimension of the key to stabilize the gradient producing the attention score. When the attention score is normalized by the softmax function to form the attention distributions, which represent the relative importance of the each key. Again, it is a what you call a probability distribution in the my query in the attentions, and this attention distribution is multiplied by the value v matrix to derive the attention value which is used to update the model representation. So here this is a scale dot product QKT. This is my equation of the scale dot product square dot product attention to measure the attention value of a particular query and the key that enter into the large LLM models. Okay, and this is one of the case. Okay, key value catching. So there are the many attention in the requirement. Okay, every time we want to find out the scale dot products attention for the every attentions. Okay, so to avoid the computing resources, use of the computing resources, at the time there is a concept about the KV catchings. So once you compute the KV, once you computing the KV product, at the time the another requirement of the attentions. So it is the caching memory is the same with the concept to reuse the already calculated value to for the future use of the requirement. And this is the difference between the multi-head attention, multiple attention, okay, and then it is a multi-query attention and multi-group query attention. So here the MHA improve the performance as compared to the single head attention, as each head capture the context in the different surface and component of the others. MQA significantly reduce the memory bandwidth by sharing the single KV head across the all Q head, but compromise the model performance. So MQA will reduce the memory requirement, reduce the memory bandwidth, but also compromise the model performance. And JQA combine the in MHA performance better, but the use of the memory is the large. So here the GQA group query attention combine the benefit of the MHA and the MQA by assigning the single KV head to each group of the Q head that improve the both memory bandwidth and the model performance. So in the GQA, it is a less memory space and a better performance as compared to the MHA and MQA. And this is a why we require the transformer model, because of the this RNN are having the inherently sequential create the memory burden as the input sequence grow longer, limited memory bandwidth, and limited batching across the example all data. So transformer model is the basic building block of the LLM and intended for the neural network to efficiently handle the sequential data of any length. The transformer model does not iteration method, but focus on the attention-based approach to determine the input-output dependency. Okay, and the transformer model use the integer input sequencing, positional embedding to help understanding the sentence word order, providing the grammatically accurate and semantically appropriate output. The transformer architecture consists of the encoder-decoder structure, attention mechanism that is replacing the RNN and fully connected feed-forward networks. So by removing the recurrence, the model enables the parallelization that improve both the speed and performance during the training and interference and used to determine a global input-output dependency. It takes input of varying length and can change the attention. So this is the architecture of the transformer model. So here it is a encoder. So here n number of the encoder and the n number of the decoder. Okay. So this is it is not only one encoder and one decoder, n number of the encoder and the n number of the decoders. Okay. So here input, tokenization, embedding and positional. Then it is a multi-head attention, add and real norm, dense layer and add and real norm. Depending upon the type of the encoder and decoder concept and attention, this encoder are taking the input decoder is taking the input from the encoder. Again, it is following the this mass multi-head attention, add and real norms, multi-head attention. So these are the all are repeated here. Okay, and then it is a positional encoding is also the input for the decoder, embedding and tokenization and the target. So this is just part of the your this what is the dense layer and the real norms. Okay, so why we require the real norm and what is the use of the dense layer? So these are the different kind of the feed forward layer, which is a non-linear linear layer and softmax fully connected layer, linear layer, and then it is the activation function, and then it is the feed forward linear layer, then activation function. Again, it is the linear layers, and the gated linear unit, that is a non-linear GLE. So here the input is having the input, then activation function, and the without activation function with the linear layer are adding. So this is non-linear gated linear unit, and then it is a feed forward GLU. After this GLU unit, again it is the linear relay. So you can get this linear relay is the what? A neural networks. Linear relay is the one kind of the neural network. It may be the MLP or so it can be the type of the machine learning. It is a type of the ANN, artificial neural networks. Okay. So here, these are the equation of the. Now this is a simple perceptron equations. Activation function with the x w plus b, and this fmn. This whole is a 1 x, and then it is again it is the linearizations. Okay, perceptions. Like this way, this is a different kind of the different kind of the feed forward layer are used in the different model of the large language models. Some model the GPT use the different this feed forward layers, and the number of the layers, and the llama is used the different number of the layers. Okay, so these are the possible possible use of the type of the feed forward level layers in the different large language models. Okay, and now this is your normalization layer. Why we require the normalization layer? Because the your output of the neural network will be the diverse. So it is time to reduce this one. They are using the normalization level layer only. This root mean square normalization layer is used in the large language model because it's generally used to normalize the input without the recentering and the rescaling in the language model. So there are also others kind of the normalization, Bayes normalization and the real normalization. They are using in the different type of the application. Here in the large language model, they are using the root mean square normalization. It is given by the these equations. Okay, where the gamma and beta are the scaling and the shifting learnable parameter. Each feature is the mean computed over the feature dimensions. Okay, so these are the use of the normalization there. So if you just go back here, so here it is a add and the real norms, and this is your dense layer. The dense layer will be the any of the this feed forward layers. Okay, and norms layer will be the root mean square normalizations. Okay, and this is the your depending upon the multi head attention. It may be the GQA or it may be the what do you call MQA or it may be the GQA, and it may be either in the single head attention layer in the attention mechanism. So there is a many possibility of this one, and this is thus with activation functions. Okay, so this is thus idea in the sigmoid and the ReLU activation function. The negative input are become the 0. So at the time the negative aspect of the context are not considered. So for this case, there is another 3 type of the activation function are used. One is the ELU, second is the GLU, and the Swiss. So what is the ELU? It is the exponential linear unit. It is given by the this equation. Well, it is a -1 to 0 will consider. So which is not in the this part of the your either in the sigmoid or ReLU, and then it is a Gaussian error linear unit. That is the GLU is given by the this equation, and this ERF of x is given by the this equation, and then it is the Swiss function, and it is given by the this ones. So this is the just comparison of the architecture of the LLMs to analyze the different MHA, GQA and MQA. So different llama and the gamma model of the large language model, it can be considered with the, so this is the difference between the how we can compare the benefit of the MHA, GQA and MQA. So if you use the MHA or GQA or MQ, what is the benefit here? The benefit is the use of the resources of the your computing facilities. Here maybe if you use the GPU and if you use the MHA, then the memory utilization is more and the computing time is more. Okay, or either in the case of the single head attention, to reduce the use of the memory and the use of the computing computing power of the your computing facilities, then we have to use the this kind of the phenomena, this kind of the solution for the GQ and the MQA. So this is the benefit of the how we can utilize the computing powers, because we are having the deal with the different kind of the large data sets. So, okay, so this is just a number embedding size, okay, vocabulary size, number of the layer, and the feed forward dimension, feed forward dimension. So you can get the idea what are the dimension of the feed forward neural networks. Okay, number of the layers and the number of the KV heads. Okay, and these are the this is a setup we require in the to train the model of the any large language models. Okay, NVIDIA series of the different kind of the requirement about the GPU memory, number of the number of the core and everything are given in the this examples. So this is a just heat map analysis about the how it is a work with the different input sweep, output sweep, batch sweep, and the attention techniques. Okay, so if you just see, this is my this x axis is the my input length, and y axis is the my output length. Length is the from the 1 to 256. When you increase the when you sweep the input length, at the time that this number will indicate the execution time is required at the generation side of the model as compared to the overall execution time. So this 75 is indicate the in the generation stage of the LLM. It will require the 75% of the total time is required for the generations. So when you increase the input length, that time will be the reduced from the 75 to 68. For this case, 75 to 67, and then it is a decreasing in the this model. And when you increase the your output length from the 4 to 1024, at the time the your generation execution time as compared to the total time is the from the 75 to the 99. Okay, and if you increase the batch size from 1 to 8, 1 to 8, so at the time if you just compare this value 68.33 and the 26.63, so it is a decrease the very drastically. So at the time the reason is the in the generation side the operation will be the less, number of the multiplication will be the less in the case of the when you increase the input batch. Okay, so this is the case about the idea about the large language models, and this is your comparison between the configuration of the LLM models. So in this case, it is a GPT model, BERT model, Llama 2, T5, Lambda, and the Palm. So you can see the size is the parameter size. So it is a 175 billion. Okay, 175 billion size of the data parameter in the your GPT-3. T is the token. So in the GPT-3, it is the 300 billion tokens. Okay, and the LR, the running rate, will be in the form of the 6 into 10 power minus 5. The running rate is a very low in the case of the because of the large AF. What kind of the activation function? So in the GPT, it is used the Geru activation functions, and then it is the number of the real NL. What is the BS is a batch size 32K to 3200K, and the NL is the number of the real 96 layer of the transformers, and the NA8 number of the attention head is the 96, and the size of the hidden state is the 12,288, and the MCLDT, the maximum context length during the training, it is a 2048. So you can see it in all these parameters of a different different model: GPT, BERT, Llama 2, T5, and Lambda, and the Palm. The size of the parameter, size of the token, running range, everything. Okay. Now the accuracies. The accuracy can be measured with this three different benchmark: general language understanding evaluation, Lambda language models benchmark, squared Stanford question answering data set. So GPT-1 to GPT-4 GPT-4 is given the better accuracies in the all these three performance metrics, and ChatGPT will give the 75% percentage of the basic knowledge question and 64.5% for the general question. Now people are using the ChatGPT every time, so there is a possibility of the error because of the it is the 75% is the giving the good accuracy in the case of the basic knowledge question. Okay, so every time ChatGPT is not right. Okay, and at the same way for the bird, for the different context, 82% for the grammatically accuracy, 60.5 for the sentiment analysis, 94.9 for the similarity in the context, 86.5% accuracy in the paraphrase, 89.3 in the question similarity, 72.1 contradiction, 86 to 92 is the answerable query, and 70.1 to the intents. Okay, so there are the different type of the model, pre-trained model. Okay, GPT, BERT, and the XLNet and others. So there are the many version of the all these models, and their use are the for a specific use. Okay, and at the same way there is also the API based models. Okay, for the specific kind of the requirement for the contextually in the different languages, different country wise, and the different territory wise. Okay, so these are the list of the traditional ML based AI API for the large language models point of view, and this is the API based on the deep learning based large language models. Okay, so this is a machine learning also, and also it is a deep learning algorithm also in the large language models. And this is my last slide, impact on the LLMs. So there are the many positive impacts and there are the many negative impacts. Okay, so we all are like the chat GPT. Okay, so the positive is the good, but the negative are the if you just consider about the negative impact, there is the ethical concern. Okay, so if I make the content is created by the chat GPT, and I am saying it is created by me, so that is the ethical concerns. Okay, I say to the someone, I am submitting the report or something. Okay, it is we are signing the report. Ne? So at the time the what happened? It is saying it is created created by the concerned persons, and but the actually we are making the from the chat GPT. Okay, so this is the ethical concerns. Okay, and then the misinformation and the disinformation, job disbursement, data privacy, and economic impact, and regulation and accountability. If you think about this negative impact, then there is a possibility to improve the accuracy of the all these large language models. And if you incorporate this negative impact with the some kind of the modification, so there may be the possible to having the better use of the all this large language model for the betterment of the societies. Okay, so this is from the my end. Any question? मैडम कितना हुआ?
41 minutes.
Okay, चलेगा वो. Okay, any question? I think this is the end of the session. Okay, so tomorrow 9:30 we provide the breakfast. Okay, and one more thing available in the this Gyan portal. Okay, this is the Gyan portal of the IIT Hyderabad. So if you go to the running course under the Gyan lectures, okay, so at the time the this is the our code number, artificial AI and machine learning algorithm by the course coordinator and the Professor Anu Gokhale is our foreign faculty, and you can see all the videos available on this side. Okay, so you can see all the right now this is a live. Okay, it is live streaming. All are available here only. Okay, so whatever you have the query, you can see again and get the idea about all the content of this all the and this video will be available for the throughout the years. Okay, up to the when the Gyan scheme will be available. Okay, so all the lecture are available here. Okay, thank you.